Yeah, can you hear me?
Yeah, sir. Very good afternoon, sir. How are you?
Fine, thank you. My meeting is just over, 3:55. So I
Fantastic, sir.
thought it'd take some time, but then yeah.
Great, great.
Mr. Vishwanathan, you can see your slides.
Yes.
Thank you so much.
Okay.
Sir, Mr. Vishwanathan from Capgemini is there.
Yeah, I know. Wonderful, wonderful. So good. They got both
Good evening.
projects.
Good evening. Good evening, Mr. Suresh.
Good evening, Vishwanathan. You got your Hyderabad project and Bangalore project, no? Both are there, no?
Only Bangalore, Mr. Suresh.
Okay, only Bangalore, right. Okay, fine. I'm glad you have come to speak about that.
Yeah, my pleasure too.
Chaitanya, can you give the presenter for me? Let me start off. Chaitanya?
Done something. You're the presenter, right?
So we got a few messages from different colleges that they're joining. We'll just wait for 2 minutes and we'll kick off, sir.
Yeah. Is it, yeah.
It is also being taken live. I don't request from many of the colleges that to accommodate much students, they wanted the live link. It's also been live, sir. Another 2 minutes, we'll start the session, sir.
Yeah.
Sure.
Santosh, you sent that material?
Very good afternoon, ladies and gentlemen. Welcome to the national webinar on net zero energy buildings, which is the need of the hour. And this is an exclusive webinar for the IGBC students chapter who are spread across India. And let me go through the agenda for you. We're going to start off the particular webinar with the keynote address from Mr. Suresh, with the chairman from IGBC. Second, proceeded with the presentation on net zero energy building, which is the major initiative because the theme of the particular World Green Building Week, which we have been celebrating from 21st to 25th of this week. The theme is on act on climate and also on net zero buildings. So to start off the net zero buildings, the net zero energy is the one initiative taken by IGBC. The approaches and strategies of net zero energy will be taken care by Mr. Karthikeyan, with the principal counselor from IGBC, and then proceeded by the case study. It is not just a theory; it is been accepted very well across India. And one of the beautiful campus, which is in Bangalore, the Capgemini's campus, case study being given by Mr. Vishwanathan, who is the senior director from the Capgemini Technology Services India. And post it, we'll have some 10-15 minutes of Q&A, and then we'll close the session. With that, let me introduce Mr. V. Suresh, who is the chairman for IGBC, and he is a civil engineer with 54 years of professional experience in housing, infrastructure, rural and urban development, real estate development, and building environmental sectors leading to sustainable development. He has served as HUDCO in various capacities and was its CMD. And he's also the vice chairman for NBC of India and chairman Housing Sectorial Committee member and Smart Cities Committee of Bureau of India Standards. He's working closely with good urban governance initiatives for meeting the challenges of urbanization and making smart, green, and vibrant cities through work on municipality. Thank you so much for all the participants to joining, and we welcome Mr. V. Suresh to do the keynote address for all the participants. Sir. Over to you, sir.
But we have got Sandeep ji as well as Karthikeyan from IGBC, as well as our own team members. They are very actively involved, and all the student chapters who have come in a big wave, the faculty and the students of the IGBC chapters. And we are around now 252 chapters now all over the country. As a matter of fact, we're getting 1 or 2 chapters getting started today, and another one getting started tomorrow. So this is an area where, as an interface or bridge between the industry and the, most importantly, the young generation. So connecting with the young generation is the most important. As a matter of fact, my own message, which I have given for the World Green Building Week over there, is a message is igniting the minds of the young. You see, that's the most important message. If you are able to connect with the next generation of young architects and engineers of various backgrounds, civil, mechanical, electrical, would be the right way where the built environment will receive the right level of impetus that it requires from sustainable development point of view. And therefore, I'm very happy that this is one session. We have about 28 sessions going from 21st of Jan to 25th. And of course, another 10 more events taking place outside the IGBC initiated program. So roughly around 38 events are taking place from 21st to 26th. But this is the only one which is exclusively opened out for the IGBC student chapters. So therefore, my particular program are young, vibrant youth who are all looking up to careers of a large future in the built environment sector. And therefore, whatever I'm trying to address over there in the next few minutes' time is primarily keeping in view that particular target group of young architects in the making or young engineers in the making, along with the faculty, some other postgraduates over there. And therefore, and I'm very happy that all of you are joined in big numbers, and that's very important. And we would like to see how best the movement of the student chapters have substantially helped over the last 20 years time period of trying to reach out to many architecture schools, many engineering colleges, many institutes of technology, where all these disciplines are taught in the various colleges for architecture or civil engineering or mechanical or electrical, etc. And all of them are very important for the MEPF professionals in a large way, as well as the civil engineering and the architectural profession also in a very big way. And as you are aware, IGBC is the Indian Green Building Council, which is the premier green building council of the country, and under the CII, Confederation of Indian Industries. And this is the 125th year of the CII. And IGBC itself was born in 2001. And then we have about 20 years of the IGBC history coming over there. As you are aware, the whole development of the green building movement started along with the IGBC's birth in the beginning of the 21st century. And there are other building center, other green building councils in different parts of the world. As a matter of fact, today, when you want to talk, there are about 70 such green building councils in different countries, like the US Green Building Council, the BREEAM rating that you have in UK. Like that, every country are there. But we are very happy that the IGBC in the last 20 years time over started with a very small way, with one building coming over there in our own green building center, with the first platinum building here in the world. And then we have come a long way from that one building of 20,000 square feet to today we are about 7.61 billion square feet or 761 crore square feet of green footprint. Imagine 761 crore square. You're talking about a house of 1,000 square feet, shopping complex of about 20,000 square feet or 1 lakh square feet or million square feet. So we are talking of roughly 761 crore square feet of green footprint, and through around 26 rating system till yesterday. But why I'm trying to say that is we have got a 27th rating also has been added now. So we have the 26th rating covering all the asset class of building, be it a commercial building, an office building, an IT park, a hospital or a hotel or a school or a college or a campus or residential building or retail mall or industrial factory building. All the asset class of buildings are covered under the IGBC rating. And unlike other green building councils, even in India, where they deal with maximum 4 or 5 vanilla rated, same rating schemes being adopted not only for commercial building, they'll use the same thing for a hospital building, they'll use it for all other buildings, whereas we have differentiated rating depending upon the amount of energy consumption, water consumption, waste generation, the type of use required in the particular one. Therefore, primarily a rating system of green rating system is essentially utilizing all the natural resource and manufactured resources in the most optimum way. And therefore, we have integrated energy management, integrated water management, integrated waste management, and also on building materials and land related issue, and the whole green footprint to be expanded in a very large way, and also overall carbon footprint reduction, which is also an equally important component, because all these elements have enormous amount of energy for generation, which will be for production of all this material. And when you're trying to apply that in a situation over there, you got to see how you will be able to do that, by having least amount of energy to be done in the inputs, the costs that go into it, and the production of the particular building in a large way. And that's very, very important aspect. And therefore, we are all dealing, as you are all aware, in 2015, 5 years back, all the 193 countries all over the world, you should know it, it's a very important development, have joined together for creating what is called the Sustainable Development Goal to the year 2030. All the students should know what is SDG 2030. SDG 2030 is signed by 193 countries. Our own Prime Minister Narendra Modi ji was there in 2015 for this particular great event in New York, when all the countries signed this particular one. And therefore, that in the next 15 years, 2015, 2030, they'll all do everything needed to protect the environment in a large way and do sustainable development initiatives, about 17 goals under that. And each one of them are very, very important. And roughly around 12 of those goals are very important for us in the green building movement. And all the rating systems that we have adopted also respects those particular things, which are also based on those 5 Panchabhutas, which are important, the natural elements that you have: air, water, energy, and the issues related to all the natural elements that come over there, how to utilize them better. So all the rating systems are also very nicely organized to see when you plan, design, construct, and operate any particular building or commission any building, you have the least amount of energy cost coming, least amount of water cost coming, least amount of waste going out of the particular thing. Overall quality of life of the particular building is also enhanced in terms of the people staying in the building or in the occupying that area, either a place to live like residences, or a place to work like your offices, or a place to play or relax that you have, or your hotels or hospitals or schools or colleges, whatever be the area over there. So primary concerns have been of that nature. And our rating systems are always evolved, keeping in view Indian conditions. We are not copying US rating or a British rating. We have in India endowed with 95% of the clear open sky, this clear design sky. The Surya Bhagavan is available for us 95% of the time, whereas all the other countries are standard overcast sky, namely all of Europe as well as most part of America. So the rating systems also keep in view the limited availability of the solar energy, and we are having a maximum that will cover in a large way for your daylighting requirement as well as other related requirements. And we can also utilize the solar energy also into a large way. And therefore, the present topic that we have among the various rating systems that we have evolved over a period of time, has also ensured all the saving. On an average, on a ballpark figure, we'll get a detailed presentation from our team members in a very large way, and you will be able to hear also Sandeep ji and Capgemini's presentation, how they have been able to ensure those particular things in various ways. One is to reduce the consumption of energy through design initiatives in a large way called the passive design aspect, orientation of the building, the east-west area where the solar impact is more. If you're able to design so that the heat gain is as reduced as possible, and also then subsequently use large amount of energy saving features in a very large way, either in the equipments or machineries or tools. For example, if you had an air conditioning one, if maybe all you youngsters, you must be all around the age group of around 20. Maybe when you are just around 10 years old, around that time, if you want air conditioning in your house or whatever, you would have put maybe 1 ton of air conditioner for a room of around 100 to 150 square feet. And normally a room, a big living room or a bedroom or whatever. The thumb rule being 1 ton of air conditioning for 100 to 150 square feet. Can you believe technologies have leaped in a large way that today we have situations where 700 to 800 square feet of area can be cooled with the 1 ton of air conditioning, but not the same 1 ton which cooled earlier there. Technologies with the latest technologies are available by which the air conditioning load can collapse down by roughly around 80% down than what it was earlier. So that means the amount of the cooling load required becomes low, therefore the energy required becomes lower. Similarly, for the lighting fixtures and all the other the star rated features, which you will hear about that in detail. If you have your own refrigerator, your air conditioner, your washing machines, you have the microwaves, various things are all have the star rated 1, 2, 3, 4 rating. So about 2 to 3 star if you have, you're saving around 10% of energy. If you make around the 4 stars, if you're able to get into roughly about 25% of energy, like that, energy saving features become important. So therefore, a combination of what architects and engineers can build in the particular thing to bring the energy, as well as what can be brought in by the whole team of the mechanical, electric, the lift installation, your air conditioning installation, your heating installation, your pumping of the water, your firefighting installation, and all your systems to be run, etc. Everything requires energy of a very large nature. Imagine an office complex, imagine a data center. So they're all phenomenal guzzlers of energy, and they're trying to reduce that. Then on top of that, how do we do by design trying to generate energy from externally instead of the grid power coming, which is fossil fuel, namely thermal power station, which is also carbon footprint in a large way. So getting renewable energy through solar or wind or various other options, and how much of that can come in over there. Today, I'm just coming whole day. I sat through about 15 projects under the environmental impact assessment clearance of the government of India. Can you believe each one of them are bringing so much of a big airport project coming in Navi Mumbai airport, and they want to bring in as much as 50% of the energy coming from the solar there. You already have Cochin International Airport generating of the order about 38 megawatt of power, whereas actual power required is only 29 megawatt. That means all the power required for the airport is generated locally, and you still have extra power to go back. So that brings us to the larger issue of today's topic of a net zero building. And there's an important component. Net zero is a larger component around which the World Green Building Week. Why are we all together in this week? Because 70 countries where the Green Building Councils are there, they're joined together and they celebrate the World Green Building Week in the last week of September. And this time it is from 21st to 25th of September. And India, IGBC is a member of the World Green Building Council. So we are celebrating that. So the message gets disseminated into a large way. And this year's theme is also very, very importantly to deal with all these initiatives of net zero energy component as well as on water being also discussed, carbon, all these issues will come in a very large way. And to very broadly tell, a ballpark figure is roughly around 30 to 45% energy saving can come as a result of a building being green. That means your energy bill will come down, and also roughly about 20 to 30% of water saving can come down. Water amount bill also will come down. Water consumption will come down. Those details are the one which will come in the presentation in a very large way. And like that, waste, all the waste generated in the particular building can also 100% is taken care of, so that you're not sending out any of those things. Everything is utilized in the proper way. That's the type of big message that's coming. And we are happy that whatever work that IGBC has done, is receiving the largest amount of support. And as I said, after all the countries have joined together to have the Sustainable Development Goal in 2016 itself, you should be very happy and proud that the Bureau of Indian Standards, through a publication called the National Building Code of India, I'm sure all you young architects and engineers, civil, mechanical, electrical, will all be knowing what the National Building Code of India is. And that particular document brought in the chapter number 11, and that chapter is very important chapter, and that's called the approach to sustainability. All the students should know contents of part 11 of the National Building Code from first line to the last page, because that contains a whole agenda for framework on sustainable development in a large way. And we have built upon all those concepts in the particular rating system. And then another important thing that happens is, it is not enough that you show in a good design, you can do it well, and this is what I want to do, etc. And do plan it and show this is what I'll do. I want a green certificate. No, that all depends on how you actually perform and how you implement that. Work is completed, is occupied, people commission, the workers are there in the industrial floor, official people are working in the office floor, people are in the hospital, doctors, nurses, and patients. And in the hotel, you have all the clients staying there. How is it performing? You said you'll save energy. You said you'll save water. Is it happening or not? So that particular thing can come only in the building management system in a large way, as what gets measured gets managed. That's the most important rule that you should all understand. And therefore, from that particular point of view, what has been done over there is that there is a new part 12 added. That also you should see, the first building code in the world anywhere. Even part 11 is the first building code in the world. Even till today, that's the only country code available anywhere in the world on approach to sustainability. Part 12 is assets and facility management. How do you keep all your systems running? Your air conditioning system running, your lift installation running, your firefighting system running, water system running, and everything that you have in the building too. And then you will know how much you are really used, how much energy you really use. Have you really saved? Have you really saved on water? Have you really improved the quality of life inside that particular building in terms of the air that we breathe or other parameters which decide on the functional performance of the building? Therefore, we got that document available. So NetZero came in as a great latest initiative where everybody started saving energy. The need for coming towards net zero energy will come in a way by which you will be able to take care of all the requirements of the particular energy from all these other sources, which are action through design as well as reduction and all that, and then renewable energy being brought in together. So grid energy from the electricity authorities, or which is done by a private electricity company or a government electricity board, whatever, and that particular thing will bring in enormous amount of benefits on that. So therefore, today's particular discussion or the theme, the whole week is all about net zero. Net zero energy is what we're going to discuss here, and what some very good success stories are there. And I'm very happy that we are going to get a good presentation of Sandeep ji on the Capgemini project in which has come up in successfully in Bangalore. You're lucky that it's come. Thank you, Sandeep, for coming over, for being present for this particular presentation. And I'm sure my own colleague Karthikeyan will give you a scintillating projection on our approach to the net zero building. I'm sure you will get completely convinced on that. And each one of you, when you get all these inputs, which these are never come in your syllabus, even your 4-year syllabus or 5-year syllabus, these are never brought in over there. So as a part of the IGBC student chapters, you get an opportunity to learn all this. And then this will also lead us to one more next step out of that. When you get out of the college either this year or next year or whatever, or after postgraduate 2 more years, you also will have an opportunity to become an IGBC accredited professional. The green education is also an important component. When I'm talking to a gathering like each one of you youngsters, I got to reach out to tell how, in addition to your BR or a BE or a BTech or BSc engineering, whatever, you are able to put at the end of your name an IGBC AP or IGBC accredited professional. Take my word, in the market, you are being looked upon as a larger product than your basic engineering degree or architectural degree. So therefore, this examinations that we are conducting, we are now doing it every fortnightly, and we are doing it now entirely online. And mind you, you don't even have to come to an office or an examination center. You can sit in your home and take the examination. And they are all online, and little amount of training that's required, or we can organize that. And each one of you should aspire, along with your degree, to also become a professional on that. Well, I don't know, shouldn't I have taken a little more than what I should have taken time on that? I understand, because you have to hear both these wonderful speakers who are going to roll out more information. There's also a Q&A coming towards the end. I'll also try to stay as much as possible. All I want to do is wish yourself well. NetZero energy is coming now, and in another month's time, NetZero water is going to come. Our rating for NetZero water will come. The third in that particular series is going to be NetZero waste coming. So NetZero energy, NetZero water, NetZero waste, and the last one is going to be NetZero carbon. Now, India will be having all the 4 ratings coming on that. One is already done and is already run. Many projects have come. Water will be done in October during the Green Building Congress. We will launch it. The other 2 will also be coming very shortly. And you will be therefore happy that this concept of NetZero component should be known to all of you very well. One is to reduce as much as possible. Second one is to see how you can take the efficiency level of a larger nature, keeping the larger component of the climate changes happening, the heating that's taking place all over, the rise of the ocean water, the melting of the glaciers, and all the related issues which affects the whole rainfall component, your natural disasters taking place, your cyclones coming in a large way, thunders, and other related. We are trying to see how best all this can be minimized with all interventions which are sustainable. Sustainable is all about whether the planet can sustain that particular thing. All the development that's coming, because population is increasing in a big way. We are just around 32 crores when we became independent in 1947. We were 100 crores, we were about 2000. And we are now coming 2020, we are nearing 140 crores, which means that we added 40 crores in 20 years time period. Can you believe? Youngsters, you understand, demography is increasing in a large way, so development is needed. Building houses are needed, hospitals are needed, hotels are needed, schools are needed, colleges are needed, factories are needed. So when you want to do all that, you can't do creation of all this built environment, which can also affect the environment in a large way. And last point which I want to close is, we did not stop at green building alone. We also had done the green built environment. I just thought you should know that we are the only rating agency who have done. We have gone beyond buildings to the infrastructure, to what you call campuses, as well as townships or neighborhoods, to green cities, as well as green villages. How to have a whole city to be also sustainable. A large number of good smart cities already taken the IGBC rating. In addition, it has to connect people from where they live or work to where they have to go. Therefore, transit became an important component. So we have the rating system which are available for metro. All the 558 metro stations through 13 companies all over the country are all IGBC metro rated. Railway stations are coming in a big way. Airports, major airports are also coming. So transit and urban mobility is also an area. Such places also are the green building component. I would like to close with this overview I try to give about IGBC, what it is, relevance of the topic, and the presentation you're going to hear. All I want to is wish you all the best, and wish both Sandeep as well as Karthikeyan all the best for your presentation. And each one of you participants, make the best out of it. We'll be loading the whole thing on the system, on the website earlier, for you to get a full idea of the presentation, etc. So the wonderful presentation coming from both of them would also be an excellent material you can keep and treasure that, and build upon that towards your IGBC AP examination, etc. Thank you very much for the opportunity given for the presentation on this. Thank you.
Thank you, sir. That was truly a very powerful and inspiring speech from Mr. V. Suresh. Thank you so much, sir. As you rightly said, the need for the students is very much required, and you give a very larger picture on that. And also requested this particular webinar is already live, and it's going to be stay online for more than 90 days. And we'll as well put it in the gallery too in the website. Now moving on, thank you so much, sir, for joining the particular session and inspiring the young minds. Now let us move to the next important session from Mr. S. Karthikeyan, who is the Principal Counselor from IGBC and having more than 20 years of experience in handling many rating systems, not only for the buildings, but also for the products. Welcome, Mr. Karthikeyan. We request you to take over.
Thank you. Thank you, Sandeep. Mr. V. Suresh, Chairman IGBC, Mr. Vishwanathan from Senior Vice President from Capgemini, Bangalore. And students, friends, very good afternoon to you all. Today's presentation, we are going to focus on net zero energy buildings and built environment. In fact, the chairman in his address, he has given a lot of information on why we are going to go about the net zero energy buildings. The first thing is, what is this net zero energy building all about? The building. Obviously, when we have building, the building will have some amount of resource consumption, especially from energy point of view. That is energy consumption. We are all connected to the grid. What is wrong with connecting to the grid? There is nothing wrong. You need power, you are taking it from grid. But what happens generally, if you look at the power generation mix, what we have in the country, more than about 70% of the power generation is through the conventional energy sources. That means we use coal, oil, gas, all those things for producing the power. Majority are coal and gas, and of course some amount of oil for DG sets, etc. So obviously, when we use fossil fuels, the power generation it has got a larger environment impact in the world. The CO2 emission on account of burning fuels is very high. So that is the reason we are moving towards more and more the renewable energy sources. So when we talk about net zero energy building, the net zero energy building, the very objective is, on account of energy, the impact on environment should be on net basis zero. That is what we are trying to mean. Suppose if I have a building and the building operational energy consumption, should be predominantly from the renewable energy sources. That is the idea behind this. So when we talk about net zero energy building, there are multiple definitions available. So when we talk about net zero energy building, our definition is these are the buildings, those that are designed to have the lowest energy demand and high energy efficiency during its operation and maintenance. And after meeting the high energy efficiency, the rest of the energy requirement, whatever is left, that has to be met through the renewable energy sources. That means the net impact on account of the energy consumption in the building on the environment in terms of the CO2 emission, etc., is almost zero. That is what we mean. It doesn't mean that we are completely isolated from the grid. Still, the building will get connected to the grid. Still, the building will have energy consumption. But on net basis, on a year-on-year basis, on net basis, if you look at, the energy consumption would be completely from the renewable energy sources. That is what we mean. Why we are doing this? As I said, number one, the impact on the environment will be brought down completely to zero on account of the energy consumption. Number two, nowadays the renewable energy also is becoming more and more economical. Gone off those days where we used to talk about the renewable power consumption. The power cost of renewable energy is about, say, 8 rupees, 10 rupees per unit, etc. Today, we are getting renewable energy at as low as about 2 rupees 50 paise. Obviously, because of the reduction in energy cost, this makes a lot of business sense for many, including an individual household requirement. It makes a lot of business sense. That means we can significantly reduce the energy cost as well. So that is the reason this net zero energy concept is picking up. So then, how to go about a net zero energy? What is the approach? The approach, as I said, the first and foremost importance is on energy efficiency always. Otherwise, it is like, if you start using only renewable energy for meeting the entire energy requirement in the building, it is like feeding into a leaking bucket. If a bucket is leaking and you keep on pouring water, what will happen? There is no water, the water will not stay in the bucket. The same thing will happen with respect to building as well. If the building is inefficient, whatever you do with respect to renewable energy, what will happen? You will keep on adding the renewable energy capacity. And actually, your investment on renewable energy will go up. So that is the reason we always say, yes, number one, the energy efficiency need to be addressed first, and then the rest of the energy requirement should be met through the renewable energy sources. And please keep it in mind, students, the energy efficiency, the investment requirement for energy efficiency is much, much lower compared to investment requirement for generating, let us say, 1 unit of renewable energy. So 1 unit of energy, if you save through the energy efficiency, the investment requirement is much, much lower. It is in fact a very, very cost effective. That is the reason the businesses, we always encourage them to first address the energy efficiency and then address the renewable energy. So when we talk about from the building point of view to address the energy efficiency, there are multiple aspects that need to be addressed. For an example, by design, when you want to go for net zero energy building, you need to start with the design aspects. When we are talking about the design aspects, starting from the passive measures, you need to address the energy consumption in the building. Then you need to work on the active measures. When I say active measures, these are the equipments and system you are going to put in the building. Those efficiency we need to address, and then we have to look at the renewable energy sources. So when we talk about the passive measures, there are a variety of measures that we can implement in passive. Passive in the sense you are going to incorporate as part of the building design, building envelope itself. For that, you need to understand what is the breakup of energy consumption in a building. Typically, if you look at this is the breakup. I am not saying this is the breakup of any building. It's a typical energy consumption. For an example, about 60% of the energy consumption happens in case of an air-conditioned building is on account of air conditioning alone. So 60% of the energy goes for air conditioning. The second, if you look at it, is more in terms of the lighting, and then some of the miscellaneous equipment and ventilation fan, etc., etc. So obviously, the major focus is on addressing the energy consumption on account of air conditioning. Why on account of air conditioning? It is because of the heat load that come into the building. What does that air conditioning do? The air conditioning actually removes the heat load in the building. So the heat in the building, that is the reason it is able to maintain the temperature. So the objective is we need to understand, okay, how the heat gain is happening in the building. What are the ways and means by which the heat gain is happening in the building? There are a variety of avenues through which the heat gain is happening in the building. Say, for an example, even the wall absorbs the heat and conducts the heat into the building. The glazing you use, nowadays it has become more common to use more and more glazing in the building. So the glazing not only allows the light to come in, it also allows the heat to come in. So glazing need to be addressed. There are internal heat gains in the building as well. For an example, you have 100 people inside the building. Each one has got their own heat that is emitted in the surrounding. So the people also contribute for the heat gain. The light we use, the heaters we use, the computers we use, all these contribute to the heat gain in the building. In addition to that, the heat you gain through the roof, all those things are leading to the heat gain. So we need to address these heat gains. So if you are able to reduce the heat gain, obviously your air conditioning load will come down. So to improve the energy efficiency, what we need to do? First, we need to cut off all these heat gains. How are we going to do that? That is what is all about energy efficiency by design. Later, we can work on the equipment. The first and foremost thing is what is the leakage that need to be cut off. So we need to look at how we are going to minimize the heat gain in the building. The approach what we suggest always is in terms of improving the efficiency is number one, in terms of cutting off the heat gain, we can look at the building orientation by design. The orientation also contributes for heat gain in the building. I will explain this about in subsequent slides. The second, the envelope measures. The envelope, what we are going to use, how efficiently we design the envelope. This is also going to contribute for the heat gain. The kind of wall you construct, the kind of glazing you go for, the kind of shading devices you go for, all these can contribute for improving the efficiency, reducing the heat gain. Third, we need to look at the equipment and system. As I said, we are going to look at the air conditioning system, the lightings, pumping systems, the motor, all those equipment. And fourth is all about the controls. We will get into the details of all this. And last but not the least is about the commissioning. It is we will also see what is this commissioning and how this commissioning is going to improve the performance of these equipment and contribute to the energy efficiency of the building. See, the first and foremost things, as I said, the orientation. For an example, you look at this building. It is a simple example where the building is, east-west facing, and you have some arrangement with respect to glazing as part of this building envelope. So the point is, we all know the sun, rises in the east and sets in the west. There is nothing new in it. Everybody knows. But in tropical country, what happens if you look at the sun path diagram? Majority of the time, the sun travels to the south and then sets in the west. So what happens when it travels to the south throughout the day? More heat gain is happening in the areas where the building envelope which is exposed to the south. So obviously, the south and the west, especially in tropical countries, they gain more heat. So the idea in the building is how we can eliminate the heat gain in the south and west. How we can make that portion more and more resistive to the heat. For an example, if you can rotate the building, probably we can do the simulation and then keep rotating the building and then see in which direction the sun radiation is lower on the building. Can we take advantage of the adjacent, the trees or adjacent building even? For example, in cities when we are building the buildings, if the nearby building is tall enough, the shading of the building can also contribute to the reduction in heat gain in our own building. So we can do this through simulation and then understand, okay, can we rotate this building? Can we just tilt this building? That is also possible if you can do it by design. But what happens is majority of the time, the plant orientation is what deciding the building orientation as well. So we will have a lot of limitation on the tilting part of it, the orientation part of it. So what we need to do, we need to look at the other measures in terms of reducing the heat gain. For an example, can I reduce the glazing in southern side so that the heat gain in the building is reduced? Can I go for additional shading devices in the southern side and the western side? So like this, if you look at this, in northern side, we have got more glazing here, whereas southern sides, you go for less glazing and additional shading devices. And in the western side, can you go for the non-air conditioned areas, something like corridors, the storage device areas. So these areas are non-air conditioned. So because of that, the heat gain in those areas will come down. In the sense, the air conditioning requirement is not there, and then that can reduce the energy consumption in the building. So typically, by addressing the orientation part, a building can reduce the energy consumption to the extent of at least about 2 to 3%. But you may wonder, what is this 2 to 3%? Is it very significant? Yes, it is significant because it is going to be there throughout the life of the building. Let us say if the life of the building is for about 50 years, the next 50 years, you are going to gain out of this 2 to 3% reduction in energy consumption. The second aspect in terms of the envelope. As I said, envelope nowadays it has become common to go for glazing devices. How much is too much? This is the question we always ask this. Because the glazing is one, it gives an excellent connect to the external environment for the occupants. Second, it also brings in a lot of daylight into the building. Obviously, there will be a reduction in the lighting load. I fully understand there is a reduction in lighting load, and then there will be a reduction in energy consumption. But what happens? This glazing also brings in a lot of heat along with the light. So, but this heat need to be addressed. I cannot completely eliminate the heat. So the heat will contribute to the heat gain in the building, and then the air conditioning load will increase, and obviously the energy consumption will also increase. That is the reason we work on in terms of going for high performance glazing. The high performance glazing in the sense, nowadays you might have heard about double glaze glazing, are triple glaze DGU and TGU units. So these units are nothing but what happens, you have two glasses, and between two glasses you create a vacuum and then fill in with inert gases, so that what happens, it acts as an insulation. So you have two glass put together as a double glaze units, and the heat gain because of this double glazing comes down. There are certain parameters we need to look at in terms of glazing also. Say for an example, we work on the U value. U value is nothing but it is a factor which governs the heat gain on account of the conduction. So we all know the heat transfer happens on account of three aspects, isn't it? The conduction, convection, and radiation. So in case of a building, you gain heat on account of all the three. Conduction is also happening in some way. Convection is also happening from air to the building and the building surface and glaze, and also the radiation, which is a direct heat gain, which is a major component. So the U value addresses the conduction heat gain. There is something called shading coefficient or solar heat gain coefficient, SHGC. I will also talk about that. And third parameter we talk about is a visual light transmittance. Friends, my chairman has highlighted this. Many of these concepts you might not have read during your curriculum, but these are the things you need to learn when you get into industry a lot. Because when you are getting into a design firm, or when you are getting into a construction industry, or tomorrow you are going to operate the building, all these will help you in terms of understanding how we can work on reducing the energy consumption. So this diagram highlights how the heat gain happens through the windows in a building. There are many ways. As I said, there is a direct heat gain happening. So it is on account of the radiation. So the external atmosphere is at a temperature of, let us say, 40 degrees centigrade. Okay. So the air is at a temperature of almost 40 degrees centigrade. So from air to the glass, there is a convection heat transfer happening. And again, within the glass, there is a conduction heat transfer happening. And again, the inner atmosphere is at only about 24 degrees centigrade. So the heat gain it happens from a hotter surface to the colder air. So that is how the heat gain is also happening through convection as well as conduction and the radiation. So in all ways, all aspects, the building gains the heat. Now, how are we going to reduce? As I said, we are going for high performance glasses for reducing the heat gain. The U value helps us reducing in terms of conductive heat transfer. I'll just give you a simple example. What is this U value does? See, if you take a plain glass, the plain glass will have a U value of about 5 to 6 watts per meter square degree Kelvin. That means for every meter square area, it will allow 5 to 6 watts per degree Kelvin difference. That means if the temperature difference between inner and outer atmosphere, if 10 degrees centigrade, it will allow 50 watts of energy to come in for 1 square meter area. Where on the other hand, if you look at the high performance glass, the U value is only about 2. Typically 1.7 to 3 you are looking at here, typically is about 2. That means it will allow only about 20 watts of energy to come in, 2 into 10, 20 watts of energy to come in. So see the difference. A single glass allows about 60 watts of energy to come in, whereas the high performance glass allows only 20 watts of energy to come in. It reduces the heat gain by 1/3. So obviously I need to look at a high performance glass to reduce the heat gain. Very similarly, if you look at the shading coefficient or solar heat gain coefficient, solar heat gain coefficient is nothing but it reduces the direct heat gain. Many of us know in a simple way. Say for an example, in our cars earlier we used to have the sun film, isn't it? The sun film is nothing but a black film we put on the car windows and the doors. So in the car glazing, when we put the sun film, what happens? The heat gain into the car comes down. This is nothing but we are reducing the solar heat gain coefficient. The same thing, we don't put it on the general building glass, rather we built in the property as part of the glass itself. This can be done. So when you are reducing the solar heat gain coefficient, let us say from a plain glass will have a solar heat gain coefficient of as high as about 95%, that is 0.95. That means 95% of the heat it will straight away allow to come in. So when you have this high performance glass, with a shading coefficient of 0.5 or 0.6, obviously it reduces the heat gain by 50%. Okay, so these kind of glazing we choose in terms of reducing the heat gain. Similarly, we work on the walls and roof. So walls also we need to look at what is the U value, and the concrete roof, how are we going to address the heat gain to the concrete roof? Can we go for an additional insulation so that we can reduce the heat gain? Because this is going to act as a thermal mass. You all might have seen in our houses also, in villages, we used to put an additional thatched roof on top of the roof for reducing the heat gain during the summer season. What we are trying to do? We are trying to minimize the heat gain. We are trying to keep the air in between as an insulation. Okay, that helps us to reduce the heat gain within the building. The similar concepts, how are we going to do by putting an additional insulation here? See, one thing we need to understand, especially in flat buildings, like when I say flat buildings, hardly about one or two stories, where we need to be very careful with the roof, because roof contributes for major amount of heat gain in the building. So the efficient roof is more important with respect to the flat buildings or with one or two stories. Whereas in case of multi-story building, the roof area is very small compared to the other areas. The wall is the one which is going to gain the maximum amount of heat. So in case of multi-story buildings, we need to be even more careful with respect to the wall. We need more and more efficient wall in case of multi-story buildings. There are multiple options available in terms of addressing the heat gain in these walls and roofs. For example, you can think about, as I said, you can think about insulation, you can think about hollow bricks, you can think about fly ash blocks. So that these are the ways and means by which you can reduce the heat gain, because the U value of these are much lower compared to a conventional red brick what we used to have. AAC block is something which is an advanced block which reduces the heat gain significantly. So there are multiple insulation materials available depending upon the cost economics, depending upon the overall the U value we are going to gain with respect to other materials. We choose these insulation materials and then reduce the heat gain in the building. Similarly, with respect to the roof also. So the third system is about the equipment and system. Okay, we talked about the building design in terms of orientation. How are we going to do that? Second, we talked about how the envelope is going to be need to be made more efficient, and then we are going to look at the equipment and system. When we are looking at the equipment and system, obviously air conditioning is a major area we need to focus on. When we talk about air conditioning, we have to look at what is the coefficient of performance. Many of the mechanical engineers and the electrical engineers, you might have studied about the air conditioning system. You might be knowing what is COP. COP is nothing but coefficient of performance. It decides how efficient the air conditioning is. So higher the COP is better. We need to look for better COP. There are many aspects available in terms of improving the energy efficiency in the air conditioning system. For example, going for variable frequency drives or going for heat recovery wheels in economizers, a better building management system. All these can contribute for air conditioning system. The diagram, what you are seeing on the slide, is the comprehensive air conditioning system. It has got about, in fact, four cycles. One is the refrigerant cycle, the chill water cycle, and the air cycle. In each of the areas, there are multiple measures can be implemented to reduce the energy consumption in a building. So, for example, it is advisable to start from the end user level. We need to go for a better enthalpy control system. We need to go for a better temperature control system. Go for a variable frequency drive with a feedback control so that you can reduce the energy consumption. So all these parameters need to be looked at in terms of how efficiently we can operate the air conditioning system. Another aspect with respect to the active equipment is related to the lighting. The lighting, it has taken various generations to come to the level of LEDs. The overall light density is what we are looking at nowadays, the light power density. light power density is nothing but how much of lighting energy consumption is there per unit area of building. It could be per square feet or per square meter. Typically, for efficient lighting system, it should be less than about 1 watt per square feet. That is a norm. But nowadays, with the advantage of the latest technologies with LEDs and also the efficient controls, we are able to bring down the light power density as low as about 0.25, 0.3. There are areas, there are buildings which have demonstrated that the light power density is as low as about 0.3 as well. So to that extent, we can work on in terms of reducing the lighting energy consumption. Again, here the approach is very simple. One is you have to reduce the artificial lighting as much as possible by bringing in more and more daylight. Then second, you need to work on efficient lighting system. And third, you need to work on the control systems. So with this, we can easily reduce the lighting power consumption. And fourth aspect is more related to the controls. There are a lot of control mechanisms available nowadays. Many of you might be knowing about this building management system. Building management system is a very effective control system. Why building management system? Because I can control sitting in one place the equipment across my building. Because it is not a simple building. If you look at a large 1 million square feet or 2 million square feet buildings, so it would be very difficult for manual controls. You do not know what is happening at some part of the building. So these building management system helps you to understand this equipment operation, helps you to understand the parameters. You can very closely monitor, and accordingly you can control. There can be automatic controls that can installed as part of the BMS. More so with respect to building management system is you can collect the data. You can measure and collect the data, and once the data is available in your hand, you can analyze the data and take the predictive and corrective measures. You can predict when the equipment is even going to fail. So accordingly, you can take the predictive measure. Okay. If something had gone wrong, you can take the corrective measure. So it is a very effective tool in terms of controlling all the equipments and system in the building, and also very, very closely monitoring the system. Okay. This is a small snapshot of the building management system in our office. We just thought of sharing with you. And the last aspect is the commissioning. Many a times what we do is we select a very efficient equipment. We go for an excellent control system, but the building, the equipment may not operate efficiently as we perceived at the time of design. There could be many reasons between, by the time you install, by the time you operate, there could be many reasons why the equipment is operating inefficiently. So that is the reason we insist on the commissioning part, where a third party should come and verify the equipment, study the equipment, do an energy audit, and then say, yes, this is the reason, this is the original design performance, this is the present performance of the equipment, and this is the deviation, and these are the reasons for the deviation. So if you know the reasons for the deviation, and you can take the corrective measures and improve the performance of the equipment. So the commissioning is very important. It has to be necessarily be done by a third party who was not involved in design, the erection, operation, etc. So having done all this, so you make your building very energy efficient. Now comes the second part. So having done the best of the energy efficiency in the building, now what we are going to do is, we are going to meet the rest of the energy requirement through renewable energy sources. So when you meet the energy requirement through renewable energy sources, that is when the building becomes net zero energy. So it will be connected to the grid. It will consume little power from the grid when the renewable energy is not available, and also export power to the grid more when the renewable energy is available. So when having got this system, you have to go for renewable energy. Now, in case of renewable energy, there are multiple options available. Number one, with the existing site availability, you can look for on-site renewable energy sources. You can go for solar PVs. You can even go for mini wind turbines. You can go for some kind of biogas-based power generation, or even some of the buildings are exploring the possibility of fuel cells nowadays. So all this renewable energy on-site you can try. Second, having done on-site renewable energy, because there are always constraints, you don't have sufficient space to meet the entire energy requirement. So then you need to go for off-site renewable energy sources. What is off-site? Okay, there is a wind farm, there is a solar PV independent power producer available who can sell renewable power to you through the grid. So you buy power from the renewable energy supplier and meet the requirement. Still, it is economical. Okay, so go for off-site renewable energy sources. There are power trading exchanges available who sell renewable energy to you. So all these can be done to meet the renewable energy requirements. Okay. So ultimately, when you do all this, what you do, you meet the entire energy requirement through the renewable energy sources, and you make your building net zero energy. I just thought of giving some small examples, some case studies. Of course, you will hear from Mr. Vishwanathan from Capgemini about his case study. A lot of work has been done at Capgemini. I will just highlight some of the buildings who have done the net zero energy building nowadays. I will start with my building, our own building, the Green Business Center in Hyderabad. We have gone extensively for energy efficiency. It's about a 20 years old building, but the equipments have gone old. So energy consumption has come down. Energy consumption has gone up. We have significantly incorporated the energy efficiency measures to reduce energy consumption at this point. And then gone for bifacial solar PVs. I would like to dwell a bit on this. When we talk about bifacial solar PV, solar PV generates energy on one side only. We all know. Here, this bifacial energy solar PV, it will generate power on both the sides. What we do is on the surface, what we do, we go for high SRI coating, solar reflective paints coating. So the solar energy, when it falls on it, it will also get reflected back. So this panel, it will generate energy on both the sides. That is why it is called bifacial solar PVs. So obviously the power generation on account of bifacial is much higher. Suppose if you look at the efficiency of conventional PV is about 17%. Here we get about 20% efficiency because the energy generation is higher. So you can have more generation with respect to a limited space. So this is the way we have achieved net zero. The entire energy requirement is met through the renewable energy sources. There are multiple buildings. Say for an example, Godrej and Boyce building, it's an office building in Mumbai. They have also gone for net zero energy by going for both on-site as well as off-site renewable energy sources. A warehouse in the sense where we store the products and materials. This is a warehouse in Mumbai. Gopikan terminals, they also have gone for net zero energy. You will hear more from Mr. Vishwanathan about the Capgemini campus from Bangalore. They have achieved the net zero energy status. There is a training institute in Jaipur by ICICI Foundation. They have gone for net zero energy by going for extensive renewable energy sources. There is a house in Chennai. Bauer Zero Energy Home, a house also has gone for net zero energy system. So friends, what I'm trying to say is, it doesn't matter whether you have a building of office building or a commercial building or education institution, a college, anybody can go for net zero energy. So it is a concept, it can be applied anywhere. So this is how I would like to sum up, gentlemen. Friends, there are excellent opportunities in terms of reducing energy consumption as well as going for increased renewable energy sources and make it a net zero energy building. Obviously, because of two reasons. Number one, it makes business sense. When I say business sense, that means you can reduce the energy cost significantly. Number two, you can also reduce the environment impact significantly. So these two reasons are driving the net zero energy concepts. So from students' point of view, these are all some glimpses of concepts we thought of sharing with you. You all have studying your own hardcore courses. It could be civil, mechanical, or electrical engineering, or architectural courses. Over and above that, the industry needs something on, some more knowledge with respect to the green, the sustainability, the kind of net zero energy concepts. These things we bring into our green education program. It is a practical course on green belt environment, especially for architectural and engineering college students, for any discipline for that matter. Our objective is to train the students and make them ready for absorption in industry. They should directly contribute to the industry. These courses are being conducted. In fact, we are working with the Vishweshwaraya Technology University. We are jointly introducing the green education program in all their engineering colleges. We are developing a separate course content on this, and these courses are also available, online for you. You may join these courses and get benefited. So at the end of the course, you get an opportunity to become IGBC accredited professional associate. As a student, you will go through this process, and you will gain more knowledge related to the green building, net zero energy concepts, and you skill yourself better so that you get a better placement in the industry. So these are some of the points I thought of sharing with your friends. I wish you all the very best. Any questions or clarifications, I would be happy to discuss with you after this. Thank you very much.
Thank you so much, Mr. Karthikeyan, for giving complete concepts on net zero buildings for the students. Sona Chaitanya, can you give the share option to me? For the needs of the time, sir, I request Mr. Karthikeyan to stay back. After completing Mr. Vishwanathan's presentation, we'll take the question answers after that, sir.
Sure.
Yeah. Now we have the next important session, which is the case study on the net zero buildings. We have Mr. Vishwanathan, who is the senior director senior director in the departments of Engineering Services and Sustainability, Corporate Real Estate Services, leads energy efficient programs, and he's also being part of the sustainability and digitization of real estate space for Capgemini. Is majorly part of the development and maintenance of large campuses facilities, including engineering and maintenance, infrastructure project management, and majorly the key factor for getting the platinum certified building with sustainable energy consumption and as well as sustainable energy generation. And he's also responsible for design and implementation of various energy saving techniques, green initiatives within the organization, and also on the digitalization of process and continuous improvement. In fact, the Capgemini Bangalore is India's first net zero energy platinum rated campus by Indian Green Building Council. We welcome you, sir, for the Students Chapter's national webinar on net zero building, and request to take over.
Thank you, Sandeep. Can you please enable the share content?
Hope you got it, sir.
Not yet. Yeah. Hello. Good evening, everyone. I'm Vishwanathan R. I'm a senior director in Capgemini. I look after the engineering and sustainability. And Capgemini EPIP campus in Bangalore is the first net zero energy rated campus. I will take you through some of the initiatives we have done within this campus to achieve the net zero energy status. So the campus is a 16-acre campus. We have totally 8 buildings within the campus, and it is a 12 lakh square feet, and the air-conditioned area is 7 lakh square feet. And this campus is constructed over 6 different phases, and this is a 10-year-old campus. So as Karthikeyan and Mr. Suresh clearly indicated that the major portion of the net zero energy goes for excellence in energy performance, which we have clearly indicated here. The 75 points goes for excellence in energy performance, and the balance 25 points goes for converting that energy into renewable energy. So first, what we have done in Capgemini is we concentrated on improving the energy efficiency of equipment, which means the old equipment have been retrofitted into energy efficient equipment. And once that is done, our energy consumption is vastly decreased. And once the energy consumption has decreased, we converted the balance energy into renewable energy. So what we have done is exhibited in the subsequent slides. On the renewable energy front, what we have done is we have installed 1,100 kilowatt of in-house captive solar plant PV panels, through which we could get around 15% of the energy. The balance 85% of the energy, we sourced it from external offsite solar plant. As you know that within the Bangalore city, we do not have space to install the complete solar plant to get the energy for a 16-acre campus. So the rooftops available, we have used it for filling with solar PV plants, which generated 15% of the energy what we require, and the balance 85% of the energy is sourced from offsite solar plant through the same grid. And this is a very important slide. The energy conservation measures what we have taken is 0.61. With the energy conservation measures what we have adopted within the campus, and with on-site renewable energy, we could get an EPI of energy performance index of 0.61. And as I told, 85.3% of renewable energy is procured from offsite solar plant, and 15.7% of energy is self-generated within the campus. On the 75 points on energy efficiency, since we could convert all the equipment into an energy efficient equipment, we could get complete 75 points, and 6 points we could get for 85% of offsite solar energy and 15% of on-site solar energy. Both put together 81 points we could get. We are net zero energy platform rated campus. And these are some of the initiatives we have taken to achieve the net zero energy status. As I told, we have installed 1,100 kilowatt of a solar plant, and we have used bidirectional energy meters, which means during our weekends and holidays where we do not consume energy, we export the self-generated solar energy back to the grid. And we have also in a building, especially in an IT building, as Karthikeyan also mentioned very clearly in his presentation, that 60% of the energy goes for air conditioning the complete building. And since it's an IT building, a lot of energy goes for the data center as well, which works 24/7. So what we have done in the data center is we have done a smart aisle containment for the data center, which means only the air conditioning is supplied for the racks which requires cooling, not the void space. The void space within the data center we do not cool, which I will show it in the subsequent slide. And for the air conditioning system, we have installed a variable refrigerant flow system, which is an energy efficient system. And we have also installed water cooled chillers for comfort air conditioning. Also, if there is a power failure from the state grid, we have two disadvantages. One is we'll not be able to source the offsite solar energy. And second, we'll be running the diesel generators, which consumes diesel fuel, and which also emits carbon dioxide. To reduce the diesel generator usage, what we have done is we have taken dual electricity feeder from the state board. So even if one feeder fails, the other feeders coming out from a different substations will feed our facility, so that there is seamless supply of solar energy into the facility. So as you can see, these are live examples of energy efficient equipment. You can see these are all modular UPS, which supports our data center load, all the IT equipment load, plus the workstation loads. So the modular UPS, what it means is we have UPS in very small size here, very module in nature, very small size UPS we have. So if you require one frame of UPS, here we require 5 different UPS, but what we have done is we could manage only with 3 different UPS because the redundancy is built within the smaller modules. So here 4 modules will be functioning. The 5th module will be redundant for this system. Likewise, we have gone for a modular design so that we do not waste the space. At the same time, these UPS are highly energy efficient and we could save 10% of the energy as compared to a conventional UPS. This UPS gives almost 96% efficiency, and during the nights as well as the weekends or holidays when the UPS is not in use, these modules will go into sleep mode, thereby they do not consume any power. And when the next day when the operation starts, the sleep mode module will wake up automatically and power the loads. And these are energy efficient air conditioning equipment. We have installed the latest technology of easy fans. This is electronically commutated fans where the fans is a direct driven fans, and it is 30% consumes 30% less energy than a conventional fan, and it delivers, this being a direct driven fans, it delivers high performance than a centrifugal belt driven fan. So here we see both advantages we get. We get more CFM for a lesser power, so that these fans can be modulated. Unlike a VFD, variable frequency drive, which is required in a conventional centrifugal fan to modulate the fan, these fans are inbuilt inverter. So automatically we can control these fans, and these fans also get modulated based on the return air temperature. And all the air handling units are controlled through the building management system. And this is the typical power comparison between a conventional AC motor and a retrofitted AC fan for a single AHU. If you can see, for a 17,169 CFM AHU, the conventional motor consumes around 11.2 kilowatt of power. But in a retrofitted EC fans, it consumes only 6.9 kilowatt of power, but delivering the almost slightly even higher CFM because of a direct driven fan. And these fans have got more than 10 years of life. Multiple fans can be used. Even if one fan fails, the other 2 fans can partially support the load. And there is absolutely nil maintenance for these fans. And since there are no VFDs, there is no maintenance of these fans. And this is the server room with the containment. This is the cold air containment. These are the AC equipment. What we do is, inside this containment area, you can see the racks. So the AC which is coming from the floor grills only cools the rack, but not the void space. The void space between the racks and the data center precision AC machines, they are not cooled. Only the rack area is cooled by the containment area, so that we could reduce almost 40% of the energy which is being spent otherwise on a PACs. If you can see this area, these are void space area where you cannot see any grills. The grill area in front of the rack is closed through a containment, so this void area is free and no cooling takes place here, and only the rack is cooled. So the rack gets better cooling as well as our energy is reduced. And as part of the digitization, we have also installed the cooling optimizer. The cooling optimizer, what it does is, it is a completely digitized architecture. In the digitized architecture, there is a sensor module which is installed in front of the rack, and there is a PAC control module. PAC stands for Precision Air Conditioning Unit. There is a Precision Air Conditioning Unit control module is there. And through a ZigBee protocol, wireless protocol, there is a wireless network manager which communicates to the AI engine. This is the engine, artificial intelligent engine, which controls the PAC through this wireless PAC control. What happens is, this sensor module will sense the temperature in front of the rack and communicate through this wireless network manager and inform the AI engine that this is my temperature. In front of the rack is 22, 23 degrees centigrade. It will communicate through this wireless network manager to this AI engine. The AI engine in turn through the wireless network manager communicates to the PAC control module So switch on, switch off, or in fact modulate the PAC fans based on the load, so that there is no fixed PAC which is running to maintain the data center temperature, but the data center temperature is managed as per the temperature in front of the rack, which is sensed through this sensor module. This is the latest AI engine which we have installed, which is called a cooling optimized solution. This has given us almost 40% energy saving for our data center. These are some of the solar plant pictures which we have done within our campus. You can see in front of the cafeteria roof also we have installed the solar panels. The solar panels using a panel cloth system has been installed on top of the RCC roof. In fact, even the water body, we have installed a solar gazebo. This is a completely Wi-Fi enabled campus. So if two colleagues wants to have a meeting over a cup, can sit in this deck and then have a chat. They'll be connecting their laptops, Wi-Fi enabled, and we have a small power point here, which is powered through the solar panel. They can power their mobile, they can power their laptops and have a meeting. Like this, we have installed many gazebos within the facility. And we have a small amphitheater. The amphitheater is also powered through the solar panels. You can see the picture of the solar panel on top of this amphitheater roof. And as I said, digitization plays a very vital role. So this is a real-time monitoring of solar plant performance through a SCADA system. So SCADA system is nothing but a supervisory control and a data acquisition system, which monitors the complete solar plant performance. And I can also show you a live view of this. So this is the live performance of the solar plant, where you can see the environmental benefits, how much power it has generated, and till now today up to 4 p.m. which has been generated, you can see the power is going down, because during the day when the sunlight is more, the power generation is very high, and slowly during the day it goes off. You can see power generation for the last week. You can see the power generation for the last month. These are all very real-time data which we use to monitor the solar plant performance. And we can also get the complete project information, where the solar panel has been installed within the facility, and various plant pictures, and how we have achieved the net zero energy status. We can get all, and this SCADA system. This is a live monitor which happens. So back to the slide, and this SCADA system also generates a daily report, and which automatically comes to our mail, which says that 5070 kilowatt hour of power generated for that particular day. Evening around 8 p.m. we will get this report, which says how much power has been generated for the day. As Karthik also mentioned in his presentation, that it is not only the energy efficiency and the energy, but a very, very important aspect in a large campus. We have to digitize the complete equipment, so that we are able to monitor it seamlessly, and we are able to control the energy by digitizing the equipment. And the UPS system, the data center cooling, network room cooling is completely digitized facility. And there is a mobile app which has been developed, where you can see the live temperature. By sitting at home, I can see the temperature, what is there in our network room, what is the power generated by the UPS, and also get the status that everything is working smoothly in the facility. And finally, it is not only about energy, as Suresh mentioned in his opening remark, that it is energy, net zero water, net zero waste, and finally all combines to net zero carbon. That's carbon neutral, where energy, water, and waste all have to be managed and treated efficiently. And we, being a responsible citizen, we should carry out this sustainability impact. So what we have done is we have also installed an organic waste converter. The organic waste converter, what it does is we have a huge landscape within the facility. The landscape generally collects a lot of dry leaves, twigs, branches, etc. We cut those branches within this organic waste composting room, cut it into tiny pieces. Even the and fruits waste, kitchen waste, which is coming from the cafeterias, those are also composted in an organic waste composting machine. This machine converts this organic waste through an aerobic bacteria process, and you can see the manure which is collected. This process takes almost 7 days. There is a heater which has been installed within this digester so that the bacteria is maintained, and there is a blower which churns the waste so that the bacteria gets enough oxygen. It's an aerobic process through which the complete waste is being converted to manure, and this complete manure, we use it within the office. The most important part of it, none of the waste is sent outside the facility, because the waste we send out of the facility which fills the landscape. So we do not give any waste for the landfill, but we use the waste within the campus to convert it into a manure, and we reuse it. So these are the things which I would like to share from Capgemini on the energy and the treatment of waste part.
Thank you so much, sir. It was wonderfully. It is like a digital tour for us to look at every aspect of the Capgemini Bangalore campus. In fact, my colleagues have been visited your campus, but I could not come. I mean, that has been taken care now. One more thing, sir, to be for your information also. During the World Green Building Week, one of the initiatives we do is the taking students for the green missions. Like your campuses, many campuses they do visit, and we take them around to understand how the things have been implemented and all. I think that is also been taken care of now. I think the virtual world is enabling the 40 plus colleges who are viewing right now are able to see your campus now through your presentation. Thank you so much, sir.
Thank you. Thank you so much.
We let sir. Thank you, sir. And we request the questions to be taken care. I request participants, if you have any questions, you can unmute and speak. You can type in the chat box.
पहले करना था.
There is one. Hello.
Yeah.
Yeah, there's one question in the chat box. It says, can we work in historic buildings with net zero energy phenomena? If so, then what will be the consideration for authenticity and integrity of heritage buildings?
Yeah, it's a very good question. Whatever building, even if it is a heritage building, the advantage with, in fact, a heritage building, it would be much more easier because many of our heritage buildings have got all these green features by design. So it would be even easier for converting a heritage building to go green as well as achieve net zero. There are many heritage buildings we want and help them in achieving the net zero, the green building status. The net zero energy status has not been implemented in any of the heritage building yet, but from the concept point of view, nothing stops us in implementing net zero energy there as well. Say for an example, if you take Secunderabad railway station, it's about 150 years old railway station. Initially we had a lot of challenges in implementing the green measures, and they have implemented very well. For an example, Tata House in Mumbai, it's a heritage building, and a museum building. We all had worked on buildings to features. And similarly, we implement the net zero energy features as well. It is a concept. It can be applied on any building. Question.
There is, yes, sir. There's one more question about who can take part in green education. Is one question come up, sir?
Yeah, there is an environment. Who all can take part in green education? Green education is meant for architectural and engineering students. From engineering, discipline is most welcome. With sustainability, everybody can learn about sustainability. But from our point of view, we can support students like civil engineering, mechanical engineers, electrical engineers, and even chemical engineers, to understand about the green concepts and also get a better placement in the industry. Okay, that is something we can support well, because these students can understand the concepts better. It will be more related to their subject. Suppose if you ask me, a computer science student, can he undergo the course? No, I won't encourage him at this point in time.
There is a question on sustainable material, Karthikeyan.
Yeah.
There is a question on what is sustainable material. Why don't you answer to the young lady?
Yeah. See, sustainable material. This is the concept which is picking up now very well. So, when we talk about green building, if you don't have green products, materials, how can we build a green building? So, when we are working on the products, the materials, we need to look at how green the product itself. You need to assess the product based on its life cycle, say starting from the raw material, the way the product has been manufactured, and the performance of the material do building, and also the end of life management. After the construction and demolition, how the material can be either recycled or reused. So looking at all these aspects, the material can be chosen for construction of the building. These materials, we call it a sustainable material. And these materials are more suitable for construction of green buildings and the built environment. So though I made it very simple, we have a separate program called Green, which the main objective is to identify and certify these sustainable products and materials so that the end user can easily choose. So for an example, if you have variety of cement products, which is the cement most suitable cement or most green cement? We have certain guidelines. Similarly, there are variety of construction blocks. Which is the construction block is more suitable for construction and which has got green attributes? So we have some guidelines. So accordingly, this material can be chosen.
Right, sir. So there's one more question over here which says, can you please suggest some energy efficient features that could be adopted in an existing building at residential or institutional buildings, which is already built without taking into the green or sustainable concepts at the time of construction?
In fact, Mr. Vishwanathan has done that only. Sir, would you like to take this question, sir? Is Mr. Vishwanathan available online?
No, sir, he's not.
He is not there. Okay, friends. When we are talking about existing building, the existing building is already built. So you will have certain challenges in terms of implementing the energy efficiency features in existing building with respect to envelope, with respect to the construction orientation, etc. You can't do anything. But you can do a lot with respect to the equipment, the systems, and the kind of retrofit measures that could be built in, etc. There are many measures. In fact, we have a separate rating system which focuses on existing building, where we work on various measures in terms of the energy efficiency in the air conditioning systems, the lighting systems, the other equipment we use in the building, and even some aspects related to the building envelope we address. All these we take care in the existing building. So it requires a separate session by itself, my friend. So I may not be able to give you only some tips. Rather it requires a separate session on improving energy efficiency in existing building.